So we are going to look at the titration maths more question-like as opposed to us doing it practically. So this might be the question. It's not going to be packaged as beautiful as this. You know now you're going to be getting a whole variety of little boxes that you're going to have to fill in things. So again, you're going to go to your extra pages at the back. You're going to generate yourself a data table. And it's really important that you get all the numbers. So we're going to go attic, we're going to go basement. We know that the attic number is the weird number in there, and we know the basement is going to be the perfect whole number, and it's going to be something that you've used a pipette to do. So you kind of look for hints in the question. So here you can see we've got 25 centimeters cubed of a 0.05 molar portion of, doesn't matter what it is, but we'll sodium carbonate. So this is a primary standard. So that's definitely your basement numbers, like so. So 25, 0.05 big M. And if we look at the ratio for the sodium carbonate, it is a ratio of 1. So that means that I'm looking for HCl values. So what are my other numbers that we have? We have 20.8 centimeters cubed. So that is definitely going to be going over here, 20.8 centimeters cubed. There's nothing else in there, and the other piece of information that we have is a ratio of 1. So this gets a question mark. I'm just going to have a little pre-scan through the question. Calculate the exact mass of anhydrous sodium carbonate required to make 500 centimeters cubed of the 0.05 molar primary standard. It says calculate the number of moles of sodium carbonate per 25. It said the number of moles of hydrochloric acid, which reacted with your sodium carbonate. It says find the concentration of hydrochloric acid in terms of moles per litre and in terms of grams per litre. So there's nothing untoward there. We have been using the W, so I'm ignoring B for now. So just looking at C part 1. If this is our W, that question is looking for this point here. The number of moles of hydrochloric acid at our end point is the number that's at this point here. The number of moles per litre is at this point here. And this is going to be a molar mass calculation using your moles per litre answer here. Okay, so that's what it all looks like. There is extra info in this question. So we're going to write it down. Extra info is 500 centimeters cubed of 0.05 molar big M. And as I've said before, by the time you are done, then it should be, you'll have used all of these numbers. Okay, so we make our funky W in the additional pages of our exam booklet. We know that this is our way in. So we set it up as 0.05 molar big M. That means 0.05 moles in 1,000 centimeters cubed. Really important that you recognize that. We know we're going down, and when we go down, we want moles per centimeter cubed. So to go from moles per 1,000 to moles to 1, we're going to have to do a division, like so. And when I do that, I am going to get 5 by 10 to the minus 5 moles per centimeter cubed. We know when we get up to this point that this flat line is everything to do with the end point, and it is moles of what was in our basement at the end point. So we have to multiply by 25 to turn that into moles per 25 centimeters cubed. So then it becomes 1.25 by 10 to the minus 3 moles in 25 centimeters cubed. At this point, we're using our ratio. The ratio is 1:1. So now I know I must have 1.25 by 10 to the minus 3 moles, except now this is going, have I done that right? Nope, I haven't, apologies. So this here should be a 2, because there's 2 moles of HCl. So I apologize for that. Let us get it again, get rid of this guy. So it's a 1:2. Get rid of this. So it's really important that you always check your numbers and make sure that you're using the right ratio, the right starting concentration, the right volumes, all of those things really important. So that doubles 2.5 moles, and this moles is in 20.8 centimeters cubed. We know that when we go down that we are doing a division, and we know we want at the very bottom to be in moles per centimeter cubed. So it's going to be 2.5 by 10 to the minus 3 moles divided by 20.8. And when we do that, we should come up with 1.202 by 10 to the minus 4 moles. We know we're going up. We know at each corner it's the big M value that we're going for. So we're going from moles per centimeter cubed to moles by 1,000. So we have to multiply by 1,000, and then we get 1.202 big M. We know we have to calculate grams in a litre. So we know that we have moles. We know we want to get to grams. You should know by now that every time we have to get to grams, there has to be a molar mass calculation. So we are looking for the concentration of HCl. So it should be a H and a Cl. So the H is 1.008. The Cl is 35.45. We add them together, we're going to get 36.458. We look at what the 8 does to the 5, it's going to be 36.46. So we have 0.1202 moles in a litre. We want to get it into grams. If I'm doing dimensional analysis to get rid of moles, I have to put my grams on top and my moles underneath. Okay, that's using our cards. When we do that, it should give us 4. Doesn't want to get rid of it. 4.382 grams per litre. The fast way, if you want to get to grams, is moles by molar mass is equal to grams. That is the fast way without having to do the cards. But you just need to make sure you know your units and how to work with them. Now, your options at this point, if you go back up and look at our question C, so you can write in the boxes C extra paper for every box that goes with this, and with this, with this, and with this, or you can write the answer and still say C extra questions, or if you are just going C extra questions and you're trying to figure out how you would annotate, then I would be annotating this as CI. Here, number 2 is the moles of the HCl at the end point, so this would be CII. Our big M value is going to be DI, and our grams per litre value that we worked out down here would be DII. And this is how I would be showing the examiner. And all I'm writing in my boxes is C extra paper. Okay, so that was the titration part of this question, but it had a beginning part. Calculate the exact mass of anhydrous sodium carbonate required to make 500 centimeters cubed of the 0.5 big M value. So we know that we are starting with the 0.05 big M. What does that mean? 0.05 moles in 1,000 centimeters cubed. So you have two ways of going about this. We want to find out 0.05 moles in 500. So what I would recommend first is turning this into grams, so 0.05 moles, turning it into grams is, when we do it the fast way, just multiplying by molar mass. To do that, I'm not going to do the calculation here, but it's Na2CO3. When you have done that, it'll come up to be 106. So you would be taking 0.05 moles by 106 grams. Moles would be underneath in terms of our dimensional analysis cards. Let me do the maths. 0.05, 106 Okay, that is giving me 5.3 grams, and that 5.3 grams is in 1,000 centimeters cubed. So because I'm trying to convert this then to 500, I would just divide 5.3 divided by 2 would give me how many grams I would need to weigh out to make 500 centimeters cubed. Okay, so that was a tiny little kick, and again I can do that in the box, or I can do it in the extra pages, and then I just give the annotation and say see extra pages. Okay, so there you go.